Sometimes when we write Lewis structures, we can write more than one good Lewis structure. The ones we just saw, there are no good Lewis structures for, they violate the octet rule. But sometimes we can draw more than one. So let's look at SO2. Here we've got 1 sulfur and 2 oxygens. So one of the guidelines for writing Lewis structures is these molecules tend to be symmetrical. So the sulfur's going to go in the middle, and the 2 oxygens are going to go on either side of it. So we'll put the sulfur here, and the oxygen here, and the other oxygen there. How many valence electrons do we have to work with here? Oxygen has how many? 6. And sulfur has 6, and the other oxygen has 6. 3 times 6, 18. We've got 18 dots. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, we'll connect the dots for the bonds. Are we good? Everybody happy? No, everybody's not happy. Oxygen only has 6. Oxygen is not cool with that. So we're going to take this lone pair from sulfur and share it with this oxygen. Now is everybody happy? This oxygen has 8, 2, 4, 6, 8. The sulfur has 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. Good. Awesome. But why does this oxygen have the double bond and that oxygen doesn't have the double bond? Why did we pick the one on the right and not the left to have the double bond? Because we started writing it that way, and that's how it turned out. That's exactly why. Well, that doesn't seem fair. Isn't this an equally good Lewis structure? Is there anything wrong with that one? No, that one's good too. They're both good. So what is the molecule actually like? Which one? It's like neither. It's not like either of them. What we do is we put a double-headed arrow, that didn't work, a double-headed arrow in between these two structures to indicate resonance. Now, when I learned about resonance structures, what I thought of, well, it resonates between them, right? It goes back and forth. Sometimes the double bond's here, sometimes it's there. That's not what happens. It's really more of an average or a hybrid. If we had either of those being correct, or if it jumped back and forth, we would observe that one of the sulfur-oxygen bonds was shorter than the other, because double bonds are shorter than single bonds. But that's not what we see when we examine an SO2 molecule. The bonds are exactly the same length as each other. And so what it is it's an intermediate or a hybrid. So here's a picture that maybe will help you. So Dad was a German Shepherd, Mom was a Golden Retriever, and here's the dog, the puppy. He doesn't look like his dad or his mom, and yet he looks like both of them, right? He's a combination. Does that make sense? You don't see a mutt dog like this that flashes between looking like both of its parents, right? My kids are hybrids. They're half Japanese, half Swedish. They look like themselves and each other. They don't really look like me. They don't really look like my husband. They're a combination of us. So the resonance structure shows the two extremes, the two possibilities, but it's actually in between. So we would draw these with a double-headed arrow in between, and that's what we use to indicate resonance. Lewis structure does not have a way to draw that intermediate average between the two. It just doesn't. This is another drawback of the Lewis theory. But to get around it, this is what we do. You can have more than 2 resonance structures. There are compounds that have 3 or 4. Let's do an example. Write the Lewis structure for the NO2 minus ion, nitrite ion. Include resonance structures. Well, again, we have NO2. We're going to put the oxygens on the outside and the nitrogen in the middle so it can be symmetrical. And then we have to count up valence electrons. There are 2 oxygens. They each have 6. And the nitrogen has 5. And what do I do with that minus sign? I'm adding 1. So 2 times 6 is 12, plus 5, and 1 is 18. On an exam, use your calculator to do that, because it'd be a shame to draw your structure wrong because you had a brain fart with addition. Okay, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Connect the dots for the bonds. Is everybody happy? No. We need to share more. We're going to take one of these lone pairs from the central atom and move it over here where we're lacking some electrons and have another bond. Now is everybody happy? Yeah. But this oxygen is saying, why does he get the double bond? Why can't I have the double bond? Oh, I deserve the double bond. No. So I forgot the charge. Charge is important. There's another possibility here. I've got a double bond here, and I could put it with this oxygen or with that. That's what alerts you to the presence of a resonance, is you've got a double bond, and where you ended up putting it was just random because I started drawing it that way, right? There was no other reason. So then what we do is we draw it the other way also. And those are the 2 resonance structures for the nitrite ion. So Lewis theory predicts a double bond here and a single bond here, or a single bond here and a double bond there. But what you actually have is more of like a 1.5 bond. Other bonding theories explain that better. Any questions? Drawing Lewis structures is a pretty big deal. Getting the resonance structures is a rather minor deal. So focus on getting the Lewis structures first, and then if you have time, master the resonance.